Hello viewers, today we will discuss the FIR filter design using rectangular window method. Okay, first of all we will design the steps and then we will follow up with an example. Steps in general, we have an desired frequency response which is given. Now we will first step we will calculate its impulse response in time domain by using inverse Fourier transform. That is HDN is equal to 1 upon 2 pi minus pi 2 pi HD e raised to power j omega desired response into our multiplier operator e raised to power j omega n and d omega, and the limits will be minus infinite to infinite, that is discrete time. Okay, after finding this impulse response, we will truncate this response to n samples, because digital filter must have some finite size. So here n is the number of samples which we have taken to define the digital filter. Generally we use symmetric arrangement so that center is at 0 and then n varies from minus n minus 1 by 2 to n minus 1 by 2. It means for 11 samples n varies from minus 5 to plus 5. That is centered around origin 0. Okay, then in next step we will pass this response through a window. Pass through window which has a response WHN. Passing through window simply means that multiplying the coefficients of HDN and WHN, multiply each coefficient. Suppose HDN is 1 1 1 and WHN is 1 2 3, suppose it is 1 4 for example, then multiplication will yields 1 into 1, 4 into 2 8, 3 into 1 3, for example. Okay, next step, after passing through a window, now we have HN. This is discrete and finite number of samples, obviously 11 samples taken in this example. Then applying the Z transform of this HN, Z transform is again a very simple procedure. That is Z transform. As it is symmetric, so we can write Z transform like that at 0 plus n equal to 1 to n minus 1 by 2, here for example 5, h n z raised to power n plus z minus n. This is h n z raised to power n plus z raised to power minus n, because it is symmetric around center. Next step, we will have to find frequency response. Frequency response is where we have the following frequency. So to identify frequency response, simply put z is equal to e raised to power j omega in the expression of z. Maybe we have to find the again realizable filter. For that realizable filter, realizable filter, we will multiply by z raised to power minus n minus 1 by 2, here z raised to power minus 5 for example, and then hz is multiplied by z raised to power minus n minus 1 by 2. N is obviously some number, n is 11 for example, then it will become z raised to power minus 5. Okay, and then finding this hz, again find the inverse z transform of this hz, and it is the hn is realizable FIR filter. Okay, now again we have to design the suppose for example design a low pass filter with desired frequency response for n equal to 11 samples, and HDE raised to power j omega, that the desired response is given as 1 or minus pi by 2 to pi by 2 frequency, and otherwise it is 0, and it may be represented in graphical form minus pi by 2 to plus pi by 2, it is 1, magnitude is 1, and HDE raised to power j omega. So first step 1, IDTFT HDN is equal to 1 upon 2 pi minus pi to pi and HD e raised to power j omega e raised to power j omega d omega. I will not integrate completely because it will be lengthy, so I just put the solution, otherwise lot of steps will result very lengthy video. Sin pi n by 2, if you integrate, put the values, it will be obviously 1 upon 2 pi minus pi by 2 to plus pi by 2, that is 1 e raised to power j omega n d omega, and further we will integrate and use that Euler's formula, you know, e raised to power j theta cos theta plus j sin theta, and that Euler's formula, sin theta is equal to e raised to power j theta minus e raised to minus j theta upon 2j. You will use this formula and you will have that sine term. Okay, sin pi n by pi n, and again the limits of n is, it is important to tell the limits. Now second step is truncating to n samples. Here n is equal to 11 given, otherwise you can assume n is equal to 5, 7, 11, odd number generally, because it will create even symmetry around origin. So 11 sample rectangular window, you can imagine it is 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3, 4, 5, 0. Around. Okay, minus 1, minus 2, minus 5, 1, 2, 3, 4, 5. Obviously minus 3, minus 4 in between. This is rectangular window. Okay. And having n equal to 11 samples. Now again truncating to Hn is equal to Hdn dash. We have used the term dash, okay, for truncation. Hd dash, and sine, it can be written as by 2 and by 2 form, 2 by 2 form. Okay, so that 1 by 2 multiply and divide by 2, 1 by 2 sine pi n by 2 upon pi n by 2, that 2 is multiplied divided. For now n are truncated to 5, that bar shows minus plus 5. Okay, so this is the basically 1 by 2 sine theta upon theta form. Okay, so for n equal to 0, that is for origin value, h0 is to be found out by 1 by 2 using L'Hospital rule, which said that when sine theta is equal to 0, then it will become 1. And further, this filter is symmetrical because theta omega, that is angle of hd e raised to power j omega, is equal to 0. So for symmetrical filters, Hn is equal to h, which is positive. Symmetrical filter like that. These values are same. These values are same. These values are same. That is symmetrical around origin. Symmetry around origin. So just going to find out the values for n equal to 1, for n equal to 2, for n equal to 3, for n equal to 4, for n equal to 5. By symmetry, we need not to find the value of minus 1, minus 2, because h1 is equal to h1, h minus 1, h2 is equal to h minus 2, h3 is equal to h minus 3, h4 is equal to h minus 4, h5 is equal to h minus 5, and this value comes out by this sine pi n by 2 upon pi n by 2 into 2. Putting the value of n is equal to 1, you can calculate it. You can calculate for n equal to 2, n equal to 3, n equal to 4, n equal to 5, and these values comes out to be sine pi by 2 for n equal to 1. For example, I am calculating it 0.3183. Similarly, other values you can calculate minus 0.1060, 0.6366. So next step, we have to calculate the Z transform, step 3. So transfer function, that is basically transfer function Hz, because it is symmetric filter, so we will use this formula. H0 center value summation 1 to n by 2 minus n minus 1 by 2 h n z raised to power n plus z raised to minus n, because it is symmetrical for both the ends. That is why we are using this formula. Now after putting this formula and values, expanding, n is equal to 11, summation becomes n equal to 1 to 5. Okay, so putting this formula, h0 we know 1 by 2, h0 is 1 by 2, h0 1 by 2 plus h1.3183 z raised to power plus 1 z raised to power minus 1 plus next value is 0, because this is 0 and equal to 2. Third value minus 0.106, that is third value 3, n equal to 3, so z3 plus z minus 3. Fourth value again 0, and fifth value, that is 0.06366 z raised to power 5 plus z raised to minus 5. And this is what the answer transfer function of LPF filter. Obviously you can rearrange it for making so much clear, or on order you can say. So realizable filter, next is realizable filter. To make it realizable filter, we have to multiply with z raised to power minus n minus 1 by 2. Okay, n is equal to 11, so we have to multiply by z raised to power minus 5. So hz will become z raised to power minus 5, and the same formula 1 by 2 plus, this is the same formula, all things. And after multiplying, you can check, this becomes 0.06366 minus 1.06 z raised to minus 2 plus 0.3183 z raised to minus 4 plus 0.5 z raised to power minus 5 plus 0.3183 z raised to minus 6, 0.106 z raised to power minus 78 plus 0.06366 z raised to power minus 10. And applying the last step, that is applying inverse Z transform, will results the final Hn, that is Hn is, you can put here, or I can put the coefficient H0, because it is symmetric, I know it is symmetric, so H0 and this coefficient are same, 0.06366. Similarly H1 and H9 coefficient are same, 0 here, and H2 and H8 coefficient are minus 0.106, and H3 and H7 coefficient are H3 again 0, H4 and H6 coefficient are H4 and H6 coefficient are 0.3183, and H5, and coefficient is center coefficient, that is 0.5. So this is the realizable filter. One thing I would like to again remind you, while passing through this rectangular window, HD-N pass through rectangular window makes it HD-N similar because but truncated to 11 samples, because I have explained that passing through window it just means that multiplying each coefficient, that is 1 is multiplied with fifth coefficient and minus fifth, and all the coefficients are multiplied with 1, so it just effect that the same values but truncated to 11 samples only. Okay, the significance is that passing from rectangular window doesn't change anything, but it truncates to now that number of samples for which window is made up of. Okay, thank you. I hope you know well.